Hi, my name is Simon, and today we're going to talk about spoofing signed ODF documents and how signatures can be used for code execution. This work was a joint work with Christian, Vladislav, and Jörg. So let's start with the basics. In this picture, we see an extracted ODF document. The content.xml file contains the main part of the visible content of the document. And the manifest XML references to all other files in the ODF package, so the application quickly knows which files are included. There are some other files in the package which contain, for example, format settings or stuff like that. And if the document contains macros, there's also a basic or scripts directory that contains a macro code. And in this example, the model1 XML file contains a simple message box macro. And if we want to run this macro when the document is opened, we also need a trigger inside the content.xml file. And to protect users from malicious macro code, there are 4 security levels. So on level very high, only macros from trusted file locations are executed. On level high, which is the default level, means only signed macros from trusted locations are executed. And on level medium, execution must be confirmed by the user. And on level low, no confirmation is required at all. And doing our research, we focused on the level default, which requires trusted signed macros. There are 2 types of signatures in ODF. Macro signatures protects only the files inside the basic or scripts directory, while document signatures are calculated over the whole package, except for the document signatures XML file. And for document signatures, there exist 3 different signature states. First, the signature is valid and trusted. Second, the signature is valid but not trusted. For example, because a self-signed certificate was used for signing. And third, the signature is invalid, for example, because the content of the document has been manipulated. So what are the manipulation possibilities? The easiest way is to manipulate the content directly in the content.xml file. But this, of course, changes the hash value of content.xml and results in an invalid signature. The second option is to add a new file, evil XML, for example, which may overlay the content of the content.xml file. But because of the missing reference in manifest XML, the application will interpret the document as corrupted. So if we add a reference to the evil XML file before signing the document and add the evil file after signing, then the signature is displayed as invalid because partial signatures are not allowed according to the ODF specification. So our last manipulation possibility is the signature file itself. In this picture, we see the structure of the signature file. The sign info part contains references and hash values to all files in the document, or in case of macro signatures, to all macro files. And in the signature properties, we find the signing time or some Exadis relevant parts. The signature value element contains the signed hash value of signed info, and the key info element contains the signer certificate. Document signatures are based on classic XML signatures according to the W3C recommendation, and macro signatures are typically implemented in the same way. But this also means that the key element is not protected by the signature. Let's start with the attacks on ODF signatures. The certificate doubling attack works for macro and for document signatures. And according to the XML schema, it is allowed to add multiple X509 certificates. So the idea of the attack is to confuse the application by using multiple certificates in the same signature file. And the attacker's goal is that different certificates are used for crypto and for the trust validation. So first, the attacker signs the macros with his own private key and his own certificate, those included in the signature file as his signer certificate. And in the second step, the attacker adds a new X509 data element to the key info element. And in this new element, the attacker inserts a public certificate from a trusted entity that the victim trusts for macro code execution. So for example, the attacker could extract a certificate from another signed document, or maybe from a signed ASMIME email. When the victim opens the manipulated document, the application checks the signature in 2 steps. So first, it checks whether the signature is cryptographically valid. And for this purpose, the first certificate is used, so the attacker's certificate that was used to sign the macro code. And since the public key belongs to the signing key, this check is completed successfully. And in the second step, the application checks whether the signer is trusted. And for this purpose, the second certificate of the trusted entity is used. And those both checks are parsed and the macro code is executed. The second attack for today is the certificate validation bypass attack. And then this attack only works for document signature. The idea of the attack is to disturb the trust validation process with unexpected certificate data in order to turn an untrusted signer into a trusted one. And all we need for this attack is a self-created and self-signed certificate. The attacker chooses the content of the document and signs it with its own private key. But of course, the victim will not trust this document because the attacker is displayed as a signer and the certificate was not issued by a trusted CA. So if the attacker manipulates the issuer and the subject of the signing certificate, for example, to Homer Simpson, who uses the safest CA in the world, the certificate becomes invalid. And this also results in an invalid document signature. However, the ODF application can verify the certificate signature only if it knows which signing algorithm was used to sign the certificate. So if the attacker changes this OID value to an invalid one, for example, to a member body, which is the OID 1.2, then the application interprets any certificate as trusted and displays a valid and trusted document signature to the victim. Let's talk about our evaluation. We developed 5 attacks and tested them on 3 desktop operating systems, 2 mobile operating systems, and 2 online services. In total, 18 applications were tested, and all applications supported macros and ODF documents were vulnerable to the macro variant of the certificate doubling attack. And 16 applications were vulnerable to the document signature variant of the certificate doubling attack, and the same 16 applications were also vulnerable to manipulations of the signature timestamp through XML signature wrapping. The certificate validation bypass attack worked only on Windows operating systems, and they are only for OpenOffice, CollaborarOffice, and LibreOffice. And Microsoft Office was only vulnerable to the signature upgrade attack. So what is the conclusion and what have we learned from this? The complexity of XML signatures is still a problem. XML signature wrapping is one example, but developers also need to deal with unsigned parts like key info element. And so the specification should be more precise. What to do with multiple key materials and stuff like that. If you want to test our attacks on your own software, you're welcome to use our proof of concept files on GitHub and our evaluation tool Dockersfile. Thank you for your attention.